There are three measures of central tendency: mean, median, mode. Mean is basically the average that we are talking about. We have done various characteristics of a good average, and what we'll be talking about here is the arithmetic mean, how you can calculate it. This is the simple method to find out the value of the mean or the average. That this is the oldest method that we have used up till now. We also have a shortcut method, which is the assumed mean method. And in this, you have to assume a mean according to you, and it could be anything. And using this formula, you can find out this particular formula: x bar is equal to a plus d bar, that is a plus summation di over n. You can calculate the mean. Now, I have done this particular question, as of I remember, from both the methods. Here I showed if you have not taken A to be 90 and if you are taking A to be something else like 85 or 80 or maybe 95, then also you will get the same answer. And I have already explained this in the previous class. We have also discussed about this was the raw data that we have, because it is like this. And here the n is 12. So it's just summation xi over n. Here it is the x bar is the assumed mean plus summation di. Di is the deviations over n. So di would be the deviations from the assumed mean from the xi's. So here you could see this is xi minus a, and this is the total PT. Now, when you are having ungrouped data like this, then also you can do it in two ways. The first method is the direct method, which is the x bar is summation fi xi divided by summation f. Now you have to get the total of the frequencies. This would be your n, right? So always in the denominator, if the frequencies are not given, then we write n. If the frequencies are given, then we total sum of them. The shortcut method again is the same. X bar is a plus summation fd over n. And in this, I have explained that they have taken assumed mean to be 8. If you don't want it to be 8, you can, I have explained it with n9, right? I have taken a to be 9, and then I got the same answer, 8.83. Now, this is when you are having grouped data, when you have class intervals, and in the class intervals they are using the shortcut method. I have calculated this using the normal method, that is the summation fi xi. In that particular thing, you don't have to calculate these. You just need to calculate fx and sum it up, and the x bar would be summation fx divided by summation f. This is your summation f. X is the mid values. I explained how to calculate the mid values at that particular time. And uh, now here they have taken assumed mean to be 35. If you don't want to take 35, how they have taken 35, that's your choice. If you don't want to take it as 35, you can take it as 45 as well. You can take it to be 25. It's particularly your choice. And if it would be different, again, the answer won't change. Answer would remain the same. Like, for example, if I'll quickly take here as b is equal to x minus 45. So as you could see, this is x minus 45 would be minus 40, minus 30, minus 20, minus 10, 0. It would be 10, 20, 30. I need to calculate what is f of d. So 3 into this minus 120, 8, 12, 15, 0, 16, 220, 150. Just sum it up. When you calculate it, then x bar would be equal to a plus summation f of d divided by summation f. So this would be equal to 45 plus whatever your summation divided by 88. So you can just calculate it. Again, the answer would be same 42.5. You can cross check. So I have already discussed about this in the previous class. So coming back to the next thing, the weighted arithmetic mean. Now, when we talk about the previous one, that was the simple arithmetic mean. So in that, the equal importance is given to all the items. But when we have different weights, like the weighing of different items means they have different weights. That means how much one is important from the other one. If you can calculate the weight, then that's called the weighted uh, arithmetic mean. So for example, to calculate the mean wage of the workers of a factory, it would be wrong to compute the simple arithmetic mean if there are a few workers with very high wages while the majority of the workers are at low wages. So they have to be same. Now, the simple arithmetic mean in such a situation will give a higher value that cannot be regarded as a representative, and that will lead to a wrong interpretation. So in this case, we'll be talking about the weighted arithmetic mean. So it is useful in those situations where the different items are of unequal importance. And this is the formula that we have for weighted arithmetic mean. Now, what you can do is you can just refer to the direct and the shortcut method. Also, we have the step deviation method. I'll be explaining that. But if you wish, because you will be getting simple questions, what I think, so you can just relate to the direct and the shortcut method only, which is related, very, very related to the arithmetic mean, simple arithmetic mean. When the weights are given, W1, W2, for respective X1, X2, and so on, then we calculate the normal mean is denoted by summation xi over n. That is the total. Now, the weighted arithmetic mean is denoted by this notation, summation wi xi, multiply the xi's with the weights upon the total weights. Here, x bar was a plus summation f di over summation fi, where di was xi minus a is your assumed mean. And we have the division method. Division, step division is that you are dividing it by h. H is the difference, the equal difference that we have. Now let us consider one question. Find out the missing item of the following frequency distribution whose arithmetic mean is 11.37. Now in this case, this is not of, okay. I'm so sorry. This is the normal arithmetic mean question. It is just I got confused between the slides. So if the mean is given to us, but we have to find out the missing value, then how we could find out? We know that x bar is summation f x upon summation f. So summation f is given. You can find out its total. The total is coming out to be 112. So on this side, this is the mean which is given to us. Denominator, the summation f. And in the numerator, you can just multiply them one by one and you can just write it like this. Now take this on this side, it will get multiplied and you can just have one variable and the other is constant. So you can also move this on the other side. So it would become minus 983, and then you would be just left with 29x is equal to 290.44. Now this is multiplying here. So when you will be taking it to this side, it will get divided. And approximately the answer is 10. Now why we can't write it in the decimal form? Because x are in the whole numbers form. So you can't write it in the decimal format. If this would have been 10.61 or 65, then it would be approximately 11, right? Now, this is the question for the weighted mean. The arithmetic mean of 50 items of a series was calculated by a student as 20. So the mean is given to be 20, n is equal to 50. However, it was later discovered that, again, I have made a mistake. Okay. I'm so sorry. Is it that he has to calculate all of the additions again and then divided by n and then he will get the correct value? No, that's the older way to find out the original method. But also we can do it smartly. And how we can find out? We know that x bar is summation xi over n, right? Now we don't know what is it. Now, in this case, what we have that x bar is 20, summation xi still we don't know, n is 50. Now, here it is divided. So, if I take it on the other side, it will become a multiplication. So, here I'll get summation xi is equal to 1000. Now, what does this mean? That if you are having 50 items, so in the x, if I'll make a table, so I'll be having here 1, 2, 3, 4, 5, 6, going up till 50. So there are 50 items. So the sum of all the 50 items is 1000. This is what it means. Sum of all the 50 items is 1000. I going from 1 to 50. Now, what would be the corrected, this is the incorrect summation exercise. What would be the corrected one? You can write here corrected. You will get it if you will add the correct number, that is 25, subtract the incorrect value, that is 35, that you misread as, then it would become minus 10. So this would be 990. Now, if this is 990, then I can calculate x bar as 990 divided by 50, which is coming out to be 19.8. This is how you can calculate the correct value of the mean. So just remember, add the correct value. This is the correct value. Subtract the incorrect value from the summation xi and you will get. Very easy to understand. Now, there are certain properties of the arithmetic mean. The sum of the deviations of the observations from the arithmetic mean is always 0. According to this property, the arithmetic mean serves as a point of balance or the gravity is of the distribution, since sum of the positive deviations is equal to the sum of the negative deviations. Now, what does this mean? If you will be calculating the x minus x bar, like in this one, yeah. So if you will be calculating here another column x minus x bar like this. So here they are saying that this would be equal. Sorry. Yeah, the sum of the deviation of the observation from the arithmetic mean is always 0. So it will just cancel and you will get the answer as 0. Sum of the squares of deviations of the observation is always minimum when taken from the arithmetic mean. So that's why we name it as least square measures of central tendency. So this is x minus x bar. The sum of this is always equal to 0. This is what they meant. Arithmetic mean is capable of being treated algebraically. You can calculate its value. This is if x1 and n1 are the mean and the number of observations of a series, and x2 and n2 are the corresponding magnitudes of the another series, then you can find the mean of the combined series by using this formula. If a constant b is added or subtracted from every observation, then the mean of these observations also get added or subtracted by it. So if you are having that each data point value in the observation, the data set is added by 5, right? Then the mean would also be added by 5 or subtracted. If it is multiplied by a constant, then the mean is also get multiplied or divided by the same number. If the observation of series are replaced by some other observations, like I did that particular question, then the mean of the original observations will change by the average change in the magnitude of the change observations. The merits and the demerits, the merit would be you can find it very easily. It requires simple knowledge of addition, multiplication. It is based on all the observations and hence it can be regarded as a representative of the given data. It is capable of being treated mathematically and it is widely used in statistical analysis. Arithmetic mean can be computed even if the detailed distribution is not known. It is least affected by the fluctuations. It represents the center of the gravity of the distribution because it balances the magnitudes of the observations which are greater and less. So that's why we always get the value of the sum of the deviations from the mean as 0. It provides a good basis for comparison of two distributions because the average is the important one, and we can calculate it very easily. But still, it has certain demerits. It was not affected by the fluctuations, but yes, it is affected by the outliers that we have. And it can neither be determined by the inspection or the graphical location. It cannot be computed for a qualitative data. It is much affected by the extreme observations, that means the outliers that I just told you. The value of the mean obtained for data may not be an observation of the data. Uh, as such, it is called a fictitious average. In the absence of the complete distribution of observations, it may lead to fallacious conclusions. And lastly, the simple arithmetic mean gives greater importance to larger values rather than the smaller values. So this was the simple arithmetic mean that we had. Now let's talk about median. Median means we are talking about the middle value of the observation. Now, the median is that value which divides it into two equal parts, and it is all called as the positional average because its values depends upon the position of an item and not on its magnitude. Now, when the observations are given, there are two ways we can find out if n is even or n is odd, right? So there are two ways in which you can find out the values. If the observations are odd, then n plus 1 by 2th observation or the 2th item would be your median, the middle value. If it is even, then what you have to do, the n upon 2th and n plus 1 upon 2th observation, find it out, take their mean, that means divided by 2, and then that will give you the median value. Just remember that even if the question is like this, you have to, if it is written in the jumbled form, you have to write it either in ascending or descending values. Here, as we could see, it is already given in the increasing fashion, so there's no need of it. Now, in this case, mm, let's do this. Okay. So in this case, this is the ungrouped frequency. And if I have a raw data, let me first take a question of raw data. So this is what I have. These are 5 points, and it is in a increasing order. So I don't have to do anything in this case. Now here n is equal to 5. So it is odd, as you could see. Now, what would be my median? The median value would be n plus 1th by 2. That means 6 by 2th item. Third item. So what is my third item? 5. So that means this is my median. Okay. If it would have been 6, n is 6. Now, in this case, we would take n by 2th would be 6 by 2, that is 3. And this would be fourth observation. So third and the fourth observation. So third observation is 5 plus the fourth observation, that is 10 divided by 2. So 15 by 2, that's 7.5. So this would be my median value. Just give me. So this is how we can find out the median for a raw data. Now, when we have ungrouped data like this, now in this case, it is always already in the ascending order. How we can calculate it? You can calculate it by the same thing. Now, what is this? The total is 95, as you could see here, which is odd. N is odd. Now, the median size would be 95 plus 1 upon 2. That is the 48th observation. Now, From the table, we understood that the 48th observation is nothing but 12. How do we found out that it is the 48th observation? By calculating the CF, the cumulative frequency. So I quickly explain how to calculate CF here. This is 10, 11, 12, 13, 14, 15, 16. So 8, now 8 plus 15, just add them. You will get this as 23. 23 plus 25 will give you 48. 48 plus 20 will give you 68. 68 plus 12 will give you 80. 80 plus 10 will give you 90. 90 plus 5 will give you 95. If you will get the total of this is also 95. We can check. So this is how we can find out the values. If this would have been even number like 96, if it would have been, then we would find out like if this would n would be 96, then the median is 96 by 2 plus the 96 by 2 would give us 48. So this would be 48 plus 1th observation. So that 49th observation, like this. So this is how you can calculate your median values. Now here in this, you can see this is the alternative method of the previous one. How would you be able to find it out that what is the answer to it? So moving ahead with the next question, which is even, n is equal to even. So here they are using the same thing that I have just spoken. 126th observation plus 127th observation. And from the table, we know that the 126th observation is 4 and 127th observation would be 5 only, because after that, up till 180, we have 5. Right? The frequency we are talking about. So it would be 4 plus 5 by 2 is equal to 4.5. Similarly, here when you will check it, if anybody has that confusion, so it would be 12 plus 13 by 2, that would be 25. So that's 12.5. Right? So that would be your median value now in this scenario. Now, the properties of the median are, it's the positional average, and it can be shown that the sum of the absolute deviations is minimum when taken from the median, as we have done it for the mean. So this implies that median is centrally located like mean. Now, the merits of the median are, it is easy to understand and easy to calculate. It can be determined even when the class intervals have open ends or not of equal width, but you cannot calculate the mean in that case. It is not much affected by the extreme observations. That means outliers. Whereas the demerit of mean was it is affected by outliers. Median can be located graphically. It is centrally located, measure of the average, since the sum of the absolute deviation is minimum. It also suitable average when data is qualitative, and you can just mark the ranks. It conveys the idea of a typical observation. The demerits are, being a positional average, it is not capable of treating algebraically. In case of individual observations, the process of location of median requires their arrangement in the order of magnitude. And if you are not writing it in the correct ascending or descending order, again, you will not be able to get the answer. In comparison to the mean, it is much affected by the fluctuations of sampling. So mean was less affected, but this is much affected by the fluctuations of sampling. The uses of median is, it is an appropriate measure of central tendency, and when the characteristics are not measurables. Median is used to convey the idea of a typical observation of the given data. It is most suitable measures of central tendency when the frequency distribution is skewed. So when it is positively skewed and negatively skewed, so we'll come up to that point in the last slide. Median is often computed when quick estimates of the average are desired. And with the open ends also, you can find out the median. Then we have mode. So going to the mode, the um, box plot in the previous classes. And see, box plot is like this. And it has 5 point summary. So why I am explaining box plot? Because it is when you will be analyzing something in doing the analysis of a data set, then you will be plotting this graph, that is box plot. So it has 5 points, that is the minimum value, maximum value, Q1, Q2, and Q3. This is the minimum value. This is the maximum value. These are called the whiskers of the box plot. Box plot is also sometimes called box and whiskers plot. So you have a box and it has two whiskers, like cat has whiskers. So in that scenario, one whisker is going up till minimum point. The second whisker is going up to maximum point. This is your Q1. This is your Q3, and this is your Q2. What is Q2? Q2 is the median value. Now, Q1 is known as first quartile. Q3 is known as third quartile. And median is known as the second quartile. Now, in the box, like you have this data right now here, where we have calculated this. Let me just erase this. Or let me just take another data that I just took 5, 1, 2, 5, 10, and 15. Okay. So in this case, my middle value was this was my median. Now, if I have this, or what would be my quartiles? Q1. Q1 quartile means when you are dividing something into 4 equal parts. Okay, divided by 4. Okay, so that's called quartile. So Q1 is n plus 1 by 4th item, like you were taking median to be n plus 1 upon 2th item. This is the case when n is odd. Q2, second quartile is 2 upon 4, n plus 1th. So that's equivalent of n plus 2th item. Q3 is 3n plus 1th by 4. So item. So now again you can calculate that. So in this case, I had this as 5. So 5 plus 1 upon 4 is 6 upon 4. So that's coming out to be 2.5. That means we can say that it is equal to the in between 2 and 5. And this was coming out to be the third item. This would be, this was 2.5, 7.5, 2.5th item. So like this, in which if I plot it here, 1, 2, 3, 4, going up till 15, 16, suppose, this would be my maximum value. This would be my minimum value. The Q2 was coming out to be 5 here. and we have many items here as well. Now, what does this say? That if you are calculating in this, the middle value that I was getting in this Q1 that I was getting was 2.5 item. That was, it would be somewhere lying between 2 and 5. So I'll take it here supposedly, and 7.5 item would be that it is lying in between these two. So I'll be taking it here because I have not plotted the whole graph. So this is my box and this is the plot. So that's again the easiest way to find out. After that, we come up to mode is basically that value or the number, the data point which has maximum frequency, or we could say that it is repeated maximum number of times in the distribution. So if the frequency distribution is regular, then the mode is determined by the value corresponding to the maximum frequency. Mode can be 1, 2, or it could be more than 2 as well, depending upon the values in the data that you have. So you can determine the mode by the inspection or by the grouping method. So this is the data. Before that, I just want to come back to this. Suppose I have 3 data sets here, A, B, C. These are the marks that the students are getting. So I am talking about 7, 8 students marks quickly. So I am getting out of 20 students are getting 9, 10, then the second student got maybe 15, then and lastly 20. Yes. So this is 8 students I had, or let me just take it to be 7 students. And here they are getting, this is it. For the second test, they are getting it as and the third one. Now, in this case, for the first subject A, when we are talking about, I have 7 students in the class, and in this particular subject, 2 students are getting 15 marks. So what does this mean? That the mode is 15. We are talking about the marks of the students here, and 2 students are getting the same marks. So the mode becomes 15, and it is known as the distribution has unimodal. Okay, if you have single mode, one mode, then it says unimodal distribution. How could you calculate the mean here? It is easy to calculate the mean. Just sum it up and divide it by 7. You can find the answer. So how would you find out the median, the middle value? What is the middle value here? The middle value is coming out to be 15. You can calculate. This would be your middle value. So median is 15. Now, in this case, what would be the median? Again, the median is coming out to be 15. In this case also, the median is coming out to be 15. So in all the cases, the median is 15. Let us now consider what is mode in this case. Now, mode in this case, 9 is repeated once, 10 is repeated 2 times, but 17 is also repeated 2 times. So what are we getting? That we are having 2 modes right now, 10 and 17. So when you are having 2 modes, then it is called a bimodal distribution. And in case of the C subject, 9 is repeated 2 times, 15 is repeated 2 times, and 17 is repeated 2 times. So the mode are 9, 15, and 17. So it becomes a multimodal because there are more than 2 modes, 3 modes. If you have 4 modes, then also it is called multimodal. Sometimes 3 modes, you can call it as trimodal. Okay. So this is the concept of mode. If a number is repeated maximum number of times, that becomes the mode. And median, we know you can calculate the middle value. So you will notice that in A marks and A subject and C subject, the mean and the mode are median and the mode are same, 15. Now, when we are having another question where the frequency is given, so these are the values, and this is the frequency in the question. So, first of all, okay, that's not the frequency, that's the whole data set that is available to us. Now we have to calculate the mode. Now, how you can find it? First, arrange it in the ascending order. So, starting with the first point, that is 3. So 3, comma, again I'm having 3, then 4. Is 4 repeated? No. Then 5, 5 repeated? No. 6, 7, 8 is not repeated again. 9, 10 is repeated 3 times. Then I have 11 repeated 2 times. 12, 1, 13, then 14, 15, 16, 17, 18, 19, and lastly 20. All are repeated 1 times. Now in this case, what did you observe? That 3 is repeating 2 times. Can it be the mode? Let's see. 10 is repeated 3 times. 11 is repeated 2 times. Do we have any other repeated more times? No. In this case, the mode is 10. Why it is 10? Because it is repeated maximum number of times, occurring maximum number of times, that is 3. If it would have been 2 times, then we would have 3 modes, 3, 10, and 11.